Welcome back, calculus scholars. Now what I want to do is kind of relate what we did last e-learning day with what we're doing today. So this question is going to be, how do we know when to use the top minus bottom integration versus the right minus left integration? The simple question I would say is thinking about, is it x equals or y equals? And I could have given you a problem that looked like this yesterday. So I have, y equals to x squared and y equals to x cubed. So that's telling me that it's kind of a top minus bottom. We can also take a look at the graph. It's helpful to, especially if it's a basic graph, just graph that basic shape of a quadratic. One thing that you'll kind of notice about those cubics is they grow up at a slower rate, and then they really start to speed up when they get beyond 1. I'm just going to actually use a little different color there to make my point a little clearer for the cubic. Now, if you don't believe me, and you can always go to Desmos.com. And you can see how x squared and x cubed relate to each other. And you can see that the x squared is on top and the x cubed is on bottom. So the top is x squared. The bottom is x cubed. And if we want to look at the intersections, well, they both share 0, 0, and they both share 1, 1. So our limit of integration is going to be from 0 to 1. And remember, we want to do top minus bottom. And our equations are in terms of x, so we're going to put dx instead of dy. So I'm going to put in my x squared. And when we evaluate the antiderivative, we're just going to do 1/3 x cubed minus 1/4 x to the 4th. And technically speaking, there is a plus c in there. And if we find out what that number is, if we plug in 1, we get 1/3 minus 1/4. And that's about 1/12 or 0.08. Now, on your homework today, my focus is going to be on having you set up but not evaluate the integrals. So I want you to kind of understand that integrals are areas between the curve, and getting you practice towards setting up those integrals intentionally, because in the real world, especially when those numbers are getting more complicated, you can go to like a computer algebra program, a good graphing calculator, and tell the calculator what integral you want it to solve, and it will spit out that number and give you that area. So on the homework, I am okay as long as you put it in an appropriate, understandable integral. All right, so it turns out that you could also interpret this integral as a right-left integral with respect to y instead. So our right on this one is y equals to x cubed, because the red is on the right side. So if we were to write this as an x equals equation, this would be x equals to the third root of y. And then the left equation is y equals to x squared, and this becomes x equals to the square root of y. And if we're setting up that integral, and it's still from 0 to 1, because those y values also have, you know, a 0 to 1 type of feature on this one. Remember, you're doing right minus left. So I'm going to do x cubed minus, well, wait. I'm not going to do x cubed. Let's, I was kind of thinking about top minus bottom. So actually what you're going to do here for this integral is we're going to do the x equals version. So we're going to say that it's the cubed root of y minus the square root of y dy. Okay, so that's kind of the integral set up on the right minus left, and you can clearly see that one is a lot better than the other to compute. So the question is, would you rather deal with, you know, fractional exponents or, you know, straight whole number exponents? So I think things are a lot better when you stick it to its top minus bottom form. You already have the equation, you know, y equals and y equals. And you could just put it right into that formula and get that exact answer. But know that you could, with a rearranging, also do the right minus left. So, moral of the story here, look at your equations. If it's y equals, this is usually going to be top minus bottom. And if it's x equals 2, then you're going to want to think about right minus left. So the next one, we're going to give you another video of maybe a little bit more difficult problem than I would give you on the homework. Maybe more in line with the difficult problem on the homework. So please stay tuned for that. Thank you very much.